So we have solved this numerical analytically earlier. A square steel bar of 20 side is subjected to an axial pull of 10 kilonewton. Determine the normal stress and shear stress in a plane inclined at 35 degree, sorry, yeah, 35 degree to the line of action of force. Also determine the maximum shear stress and the angle at which it will occur. Solve using Mohr circle diagram. So the initial solution will be same. So what I have done, I have found the area of cross section. I have the load divided by area of cross section will give me the normal stress, that is equal to 25 megapascal. Now, I had told you people to get graph paper. If you don't have graph paper, you can draw using a plain paper. Only thing is, you need all the drawing instruments. So I will be drawing it on this Abacus student version screen, right? So since I'm using the software, I'm taking scale 1 millimeter equal to 1 megapascal. So you have to choose a scale according to your paper size and the stress value. Scale 1 is equal to 1 MPa, right? This is my scale. Now sigma is 25 megapascal, so that line will be 25 millimeters. So let us go back to my diagram. This is how I have to draw the Mohr circle diagram, right? So first I have to draw a horizontal line and then on that mark sigma, find the center of that and then draw a circle. So since it is very simple, I will try to do it very quickly, right? So I am taking this as the center. I'll directly draw the circle like this, right? Now this is the diameter of the circle and I am dimensioning this. This is 25 megapascal. So I got the circle like this. Just one out. Okay. Now what you have to do? You have to draw an inclined line which is equal to 2 theta. Now theta is given as 35 degree. So 2 theta is equal to 35 into 2, which is equal to 70 degree, right? So from the center, that is here, I am drawing a line like this. So this is 2 theta. I will dimension it later. Let me just complete the diagram. From there, I have to drop a perpendicular and then I have to join this point with this point. Just check again. See, I draw a line like this, drop the perpendicular and then I join these two. Now I have to just dimension here. So from here to here, this will be 70 degree, right? So when you are drawing on your graph paper, you first draw a circle of radius 12.5 mm, right? Because 12.5 mm will be very small, you can take a enlarged scale, right? And draw the circle according to your scale. With the center, you draw a radius at 70 degree it will meet at a particular point. From that point, you drop perpendicular till it meets this x-axis, and then join this point with this starting point, right? So now your Mohr circle is complete. Now what you have to do, you have to just measure these lengths so that you will get the required things. Now this is giving me normal stress, right? OQ, this is OQ, is the normal stress. So from here to here, this is the normal stress. So let me just find that length from here to here. So this is 8.224 or 8.25. So from MOHR circle, we have sigma n, right? So this is sigma n is equal to, what is that length? 8.2 8.22 mm, which is equal to, I have chosen 1 millimeter is equal to 1 megapascal, so it will be 8.22 megapascal. Now if you have chosen different scale, you divide this scale quantity by that scale, so that you will get the actual length. So I got the normal stress, then shear stress. Normal stress on element, shear stress on element. Shear stress is represented by tau. Now what is shear stress? Shear stress is QP, that is this perpendicular length. So let us go back to here. I have to measure this length, right? So just select this. So this is 11.75. 11.75 millimeter. So that is equal to 11.75 megapascal, because my scale is like this. Now let me just check the answers. See, this is 11.75 and this is 8.2. We got same answers. Right? I got same answer. Also determine the maximum shear stress and the angle at which it will occur. So the maximum shear stress will be at 45 degree. So from the diagram, if you have to calculate, then what you have to do is you have to draw another line like this and drop a perpendicular from there, and this inclination should be 45 degree, because maximum shear stress is at an angle of 45 degree or 135 degree. Now this line, if you measure this vertical line, this will give you the maximum shear stress value. So that is coming to 8.83, right? So that is the maximum shear stress value. Sorry, it will be the radius, right? Yeah. So you have to do 2 theta. See, it is actually this height, right? So this height is 25 by 2, that is 12.5 megapascal. It is the same. Okay. Any doubts or questions in this?